All right, we now introduce AHEM, the Advanced Human Eye Model, which is available for ASAP. And its function is to allow the user to generate eye models representing various stages of the eye and any other type of optics associated with the eye. So right now we're looking at a graphic of a basic eye model, and I'm going to take you through some of the simple steps in generating this graphic and the default eye model. Alright, so it's very simple to start AHEM. We right-click in our workspace and start Auto Run. And we get a prompt screen. It's a launch screen. And it asks us three questions: a settings, default, or saved file. So right now I'm going to run the default model, but I do have the options for reloading settings that were generated before if you've been working on an eye model and you just want to reload it. And then also if you have a saved file from some previous session that you want to load. So right now we're going to default, hit 1. And now it asks me, do I want to save to a file? Well, if I save to a file called settings, then I can do iterations without retyping the word settings. I can also save to a named file, which I can reload later. I'm just going to hit OK and let it run in settings. So the first screen I get is a basic input screen, and it describes most of the factors involved in generating my model. So I can have one or two eyes. I can use a coherent or incoherent source. Right now we're going to use an incoherent one, so it's unchecked. I can choose a monochromatic wavelength, 589 microns, or I can use 4 polychromatic wavelengths, so I'm going to stick with one wavelength for now. Here I have an eye lens model choice, so I have a choice of either simple biconvex equivalent index lens that's controlled by power. I can have a gradient index lens, which is a complex shelled gradient index lens. I can insert an intraocular lens, an IOL, or I can use the Arizona eye model. So I'm going to choose that. I can also put correction on this eye if I wish. I can have axial ametropia, which means I can stretch or compress the eye. Anterior cornea Zernike pupil diameter means if I want to deform the cornea with a Zernike surface, I can do that. I can control the iris or pupil diameter. I can put targets at a certain distance away from the eye, and also change the field angle, so I don't have to look directly at the target. I can rotate the eye or the target. Down here I can select target type. So with it unchecked, I have a source target, like a point source, at 6 meters or 6,000 millimeters. If I checked object, I could pick an object target, which could be a user target, any image that you have that's a bitmap, or I can select an eye chart, an AI chart, or an EI chart. So here's where I put in my file name if I wanted to use that. I can scale it. I can even rotate the target itself, so the target will be upside down on the retina, so if I don't want it upside down, I can specify 180 degrees. Here's my retinal image window, so I specify how large a window I want to look at when that image projects to the retina. And then I have some other options here for focus. I've got an initial focus and a new best focus. Depending on what type of optics I've got set up in my eye, there will be some best focus for the retina. If I start going in my model and changing things, like putting in a lens or reshaping the cornea, I might create a new best focus. So the next time I go around and use the eye model, the retina would be at the old location. I may want to move the retina to that new best focus, or I may not. So I have that option. I can save history about the eye, so that means that I can look at rays that have scattered or rays that have hit certain objects. I can look at the rays in more detail in a ray history file. I can also insert a system that's totally independent of the eye, and it can be anything, some instrument or whatever I have that I want to integrate into the model. If the system that I'm inserting is retinal implant, I select that because that puts it inside the eye. I can opt whether or not to skip the default metrics that are generated with the eye, which are some various measurements of quality. And here are some options that I can use to set the display. So I can have 201 by 201 pixel display. I can average adjacent pixels on that display. When I draw my graphics of my eye, I can increase or decrease faceting. And then I've got a plotting factor for the rays. So I can control the amount of rays that appear on my graphics by increasing or decreasing the plotting factor. All right, so I'm going to keep things the way they are and just click OK. And then I get the next screen, which is a little more detail about the geometry of the eye. So here I've got an AZ accommodative lens power. Now this screen will be particular to the lens choice that I picked in the first screen. So here's my lens power. I can accommodate the eye. So I have a maximum of 5.5 diopters. And here I don't need accommodation, so I'm going to leave it unaccommodated. And I can place my anterior vertex in certain positions. Right now they're set up to follow the Arizona eye model, but I don't have to use those numbers. I can change them. So I've got things like lens diameter, thickness, pupil shift. I've got cornea thickness. I can rotate the anterior and posterior surfaces. I can change conic constants, corneal diameter. I can change how the iris is shaped. I've got a retinal thickness I can change. And then down here, I can look at my field that I generate when I send a source to the eye. I can look at that field in 3 dimensions. So if I leave it at 0, it won't go into that mode. But I can control a 3-dimensional point spread function through depth of focus. And then I can slice my way through that focus for resolution of that volume. All right, I'm going to click OK because I'm happy with what I have. And I generate a graphic of the eye. There's many graphics. So these are the basic metrics that I get. I also have some that are generated at the bottom of the command output window, where I have full width at half max information. I've got a 50% encircled energy. There's my initial and best focus. Well, let's look at some of these graphics. All right, we saw this plot already. Here's a retinal image 3D view and cross-section. So these 2 graphics are overlaying here in cross-section, and I've got a isometric view here. I've got a display. That's a point spread function, and I can look at that various ways. I can look at that in 3 dimensions as well. Cross-section graphic here. And then I have a retinal encircled energy as well. So these are some basic graphics, and the user can generate any type of ASAP graphics now, because all that information about the eye is available, but these are just some standard ones that many people would be interested in. So that's the default AZ model.